All right, welcome to Earth Science, everybody. So this is only if you are absent on the 10th of November. That is a Wednesday. I'm going to do exactly what we did in the class that day. If you weren't here, you're going to want to check it out. And you're going to need this map right here. So back to the survival guide. If you click that guy, it should go to a PDF. I'm not positive this is gonna work because I didn't make it an assignment and I want to clutter it all up. See if you can download that and open it in Cami on your computer. If not, let me know and we'll figure something else out. Or you can wait till you're back in school, grab a piece of paper, and do this on paper. That's how we all did it when we were here. It may be slightly easier to do, like on an actual piece of paper. Nonetheless, here's the deal. This is 2 pages of the reference table that I cut out the rest so that we can just focus on these two. We're only worried about latitude and longitudes. We're going to use this map a lot when we get to geology, bedrock geology, these time periods with all these crazy names. All of the cities that the regions can ask about are on here. In other words, they don't ask questions specifically about Pulaski because it's not on the map, but I have seen Regents questions of Watertown, Oswego, Old Forge, etc. And again, all we're going to do is worry about how latitude and longitude is set up. And then down here on the world map, kind of the same concept, only we're zoomed way out. So what I had everybody do in class was use two different colored pencils. If you are stuck at home with this, we'll use the line tool, and we'll start with latitudes. So make a line that goes from 45 to 45, like that. And I know it can be this thing can be a little fussy. Do your best. Not bad. Okay, so that's our most northerly latitude, and we'll start working our way south as we go. So a few more lines. 44 is the next one down. That's 45 north. We're going to go down to 44 north. Right about there. And again, Cami being a little fussy, you might have to monkey with it a little bit to get it to line right up. Okay, 45, 44. There's lines for like halfway. That right there, if you grab that accidentally, fix it now. We'll use that when we get to 76 longitude and up and down line, but it's also the halfway line between 44 and 45. That can be handy. All right, more. 43 to 43. Whoops, that's awful. All right, 43 to 43. Yeah, this thing's fussy, huh? You can be you can get a little have a little room for error if you want, but try to get it pretty close like this. It'll benefit you. It'll be handy. 42 to 42. Excellent. And then as far as we can go down is 41. 41 to 41. There's actually three of them on here. 41, 41, 41. And if you look at these and you say, Mr. F, that one bugs me because it feels like these are not quite parallel. If you've ever heard this idea of map projections, that when you take a spherical Earth and put it onto a flat piece of paper, things get a little bit out of whack. That happens here. On the scale, they might not be perfectly parallel. That's okay. They are in real life on a spherical Earth, but we have a spherical Earth projected on a flat piece of paper, and that messes it up. All right, cool. That's that. That's latitudes. Longitudes, which are not parallel on a global scale. Um, I had everybody with colored pencil switch to a different color. Careful here. They give you 7330. I don't know why. Arbitrarily, they only have one. This is like typical New York stuff. There's always some weird exception. They arbitrarily gave you 7330 here, 70, which is 73 and a half. We want regular plain old 73. So I'm going to start here. I guess there's a 4030. There's another instance where they did a half. My scale's off. I'm going to have to zoom out a tiny touch. All right, try it again. 73, 73. There we go. Beautiful. And this is another instance when you start doing these, you're going to see that they don't feel perfectly like grid like. If you're OCD, that can be frustrating. But I'm saying, don't worry, relax. It's going to be okay. There we go. These are going faster now. 76, 77. Note, I don't like that. Note that we're counting up as I go from right to left. 73, 74, 75, 76. 77, 78, 79, and that should do it. 80 would be over there in that little nub of Pennsylvania. All right, perfect, beautiful. That's it. Those are the latitudes and longitudes we're going to deal with in New York. When you get to the last section of the notes, you're going to have to be estimating the exact locations of cities like Buffalo, Elmira, Oswego, whatever it may be, down to the nearest minute, which can be frustrating, and it's a little bit of a trick. It's a different way to think about it. I'll say it then. I wish you could do this as decimals, but we can't. We got to figure out this whole minutes thing. So that video will be more specific on that. I do the first one for you and say, here's how it goes, and see if you guys can work it from there. Okay. Do keep in mind, though, while I'm still in purple here, longitudes count that way. We have west longitudes. Latitudes count that way. We have, no, that's terrible. We have north latitudes. Okay. That's us in New York. Always will be in those two hemispheres, which gets more confusing when we get down to this map. Now, the good news is we don't have to worry about minutes and seconds anymore. This map is way too zoomed out. You'll be to like the nearest 5 degrees or so. That'll be a very comfortable margin. The bad news is now we got to pay a lot more attention to north, south, east, and west. And to complicate that bad news, New York got a little bit crazy here with how they made this map, which I don't understand. But living here, got to deal with it anyway, right? So don't worry, we're not going to draw all these lines on there. It would get way too busy. We're only going to do a couple. So I'm going to start with a special latitude at 0 degrees, which hopefully we know the name of. 0 degrees latitude is called the equator. And we'll throw like kind of the same concept we did with the arrows. How do we count these? And this tends to be inherent for people. People get this, that you go up from the equator, those are your north latitudes, or you count down from the equator, those are your south latitudes. That's easy. What's harder is longitude. Thinking about it with this globe, it makes sense. People get that you can go north, 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 north. It points to something. There's the North Pole. We get that that's a thing, and it's easy to spot on a globe or on a map. North Pole is the place where north is. No matter what, that's easy to find. Or if we were down here, South Pole is the place where south is. It's easy to point to. It's easy to find. You can head south, 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 get to the South Pole, and you've made it. You can head north, 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 get to the North Pole, you've made it. East, west, there's no East Pole. There's no West Pole. It inherently becomes more complicated then. You can go east and east and east and east and east and continue to go east for the rest of your life. Or west, you can do the same thing. You're not going to get to the west at any point. You can go so far west that you end up in the east, or so far east you end up in the west, and it starts to just meld together, and it becomes like more difficult. And it always will be. As you guys learn to drive when you get on the thruway, there's signs for 90 east, 90 west, and one will say Albany and one will say Buffalo. And I guarantee that either you or somebody you're driving with is for a minute going to be like, wait, which way are we going? It happens. Whereas north-south is always like, yeah, north, I'm going that way. It's easy. So we gotta like unwrap that. It's difficult, but we can do it. I'll switch colors. We're going to do a line for 0 degrees longitude. Now, the equator is something like celestially. We talked about what the equator is, where it is on Earth, where the sun hits. There's no reference point for longitude. The whole planet spins underneath the sun. All of these see the sun every day. So at some point, and there was like historically, countries fought over who was going to get to have 0 longitude, and the British won. So the Prime Meridian right here is the line that is 0 degrees longitude. Nothing special about it or science-wise, other than it was proclaimed to say, here's the spot, this is it. All lines of longitude are called meridians. The special one at 0, I don't know why I'm getting that weird thing. I'll do it down here. It's called the Prime Meridian. 0 degrees longitude, arbitrarily decided by human beings. All right. From there, we've split the Earth into 2 hemispheres, the Eastern Hemisphere and the Western Hemisphere. But like, again, you can't get to the East Pole or the West Pole. So it's a little bit more nebulous of an idea. You can go east, 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 east. But where does that end? It doesn't really end at 180, but in a sense, it kind of does. So what we did, I don't know if there's a way to do dash lines on this. In class, we did like a dash line for this, and I'd rather have it in the same color. So let's switch to orange. If If you know how to do like a line function that's dashed, do that. If not, we'll be close enough with this. Don't worry. Not perfectly straight, but hey, close enough. The back, that's basically the back of the Prime Meridian. The Prime Meridian will go up to the North Pole and then down the back of the Earth at 180, which we call the international date line. International date line. Which, with time zones like we've been talking about, they took the Earth and they whacked it up into 24 pieces for the 24 hours a day. That has to meet somewhere where like the date changes. It gets a little bit complicated to think about. Don't panic about it today. It's no big deal. All we're really doing is dividing up into hemispheres and figuring out east, west, north, south, ideas like that. And don't worry about all this geology stuff. That's not for until a future marking period. Now, where we're going to get confused is first, let's do where we live. We live in the Western Hemisphere. That's all the longitudes west of the Prime Meridian up to the international date line, counting that way. People don't like counting from right to left. It feels backwards because we read left to right. But hey, that's how it is here in the Western Hemisphere. WEST for West. Okay, from 0 to 180. Not too bad on that side, honestly, as long as you can keep in mind that you count from right to left. The Eastern Hemisphere, and this is how New York State made this map. I don't know their logic. Never do. But we're stuck with 0 to 20 over here. So you go from the Prime Meridian to do the Eastern Hemisphere. You got the first 20 degrees of longitude there. And then like Pac-Man style, you go off the board, you come back on over here for the rest of the other 160 degrees of Eastern longitude. So it's like this side's from 0 to 180, no problem. This side's from 0 to 180, kind of a problem, like 0 to 20 and then 20 to 180. So I asked in class, how many chunks do we have here? And that one person guessed 3. I didn't get that one, respectfully. Some people said 4. Some people said 6. And I can see what you're both thinking. What do you think? What is the best answer for how many chunks there are? I'm going to say the best answer is that there's 4. You got this one here, which is Western Hemisphere and Northern Hemisphere. So we'd call it northwest. If you find a longitude in there, if you get asked the Hawaii hotspot, hint, hint, you'll definitely get asked that. It'd be a northern latitude and a western longitude. Or if you're down here, you're in the southern hemisphere and the western hemisphere, that'd be southwest, right? Over here, you're in the north and the east. But this little slip over here is part of that chunk. That's also northeast. I mean, there's a road somewhere in Scandinavia that keeps on going right there and just keeps on driving right there, right? It's cold up there, but it exists. That is one chunk of our Earth. These are the 4 quarters. And then down here would be the southeast. But again, this thin little strip over here also is the southeast for 4 total chunks that, yes, kind of looks like 6 because of the way that New York State divided up this map. Okay, so your job is going to be to go back to the notes like this. I did do a video explaining, like, these numbers are in there from a video. So if you're like, how the heck did you figure out 4250? Watch that 4th video in this thing, and it will show you how to estimate those, how to estimate these. Those answers are given. Steal them now if you want, but you'll need them. You'll need to figure out how to do this because you are responsible for the rest of those and the rest of those. And then you're going to come back and do this classwork, which is 10 Regents questions, as per usual, on latitude and longitude. Thanks for tuning in. So long for now.